Okay, this is from section 1.8, and this is your homework problem number 27. And we wanted to find the inverse. You look at your directions in your book, and it says find the inverse function. And then we have to verify it. So first of all, we'll find the inverse function, and that was our 4 steps. So this was our function, f of x equals 2x plus 1 all over x minus 3. And the first step, remember, instead of writing f of x, we write y. Second step, we interchange the x and y. So every time I see a y, I put an x. And every time I see an x, I put a y. And then the third step is we want to solve for y. Well, I've got a fraction in here, so I'll multiply both sides by y minus 3. This gives me a y minus 3 on the left, and y minus 3 cancels with this minus 3. So I have x times y minus 3 equals 2y plus 1. Now I've got y's on the right and y's on the left, so I want to get all those y's together. So first of all, I've got to remove this parenthesis so I can get at this part, which is part of the y's that I want. So x times y is xy, x times negative 3 is negative 3x, and the right stays the same, 2y plus 1. And then what I'll do, and I'll do this in one step, I'll subtract 2y from both sides to get all my y's on the left, and I'll add 3x to both sides to remove the 3's on the right, on the left, pardon me, and put them on the right. So if I add 3x to both sides, these 3x's cancel, and it puts a 3x down here. If I subtract 2y from both sides, these 2 y's cancel, or become 0, and then I've got xy minus 2y on the left. Now I want to solve for y, so I have y in both these terms, so I can factor out the y, and what's left is x minus 2. And that equals what was on the right, 3x plus 1. And then in order to solve for y, I want to get rid of the x minus 2. It's y times that, so I divide by x minus 2. So I divide both sides by x minus 2. So there's y. So that's the end of the third step, solving for y, and then the fourth step is all we do is we call that f inverse. So there's your f inverse, or your inverse function. So there was a little bit of algebra involved there. Okay. So take a look at that. Make sure you understand these operations because these are pretty valuable techniques, especially multiplying both sides and then regrouping our y's so we get the y's on the left, and then factoring. These are all pretty valuable algebraic techniques. Okay, now we want to verify this, okay, by showing that if each function will undo the other function, like we did on the earlier homework problems in this section. So we want to verify that. So this is my first function. F of x is this 2x plus 1 minus 3, and g of x is the 3x plus 1 over x minus 2. And now this was f inverse of x. So we want to show that these functions will actually, when we take f of f inverse or f inverse of f, we're going to get back x. So rather than, complicated with this notation, we just call this g of x, and then they're very much like the problems we were doing earlier. So first of all, let's see, is f of g of x x? So here's f, and remember our f function was 2 times something plus 1 all over that something minus 3, and in this case I put the g of x in there. All right, again, f, that's the outside function, that's 2 times something plus 1 all over the something minus 3, 2 times something plus 1 all over the something minus 3, and in this case the something is going to be the g of x. Now I'll actually put this value in now. So instead of writing g of x, I write 3x plus 1 over 2, 3x plus 1 over 2, 3x plus 1 over x minus 2, 3x plus 1 over x minus 2. So we substitute that. Now remember, if you have trouble seeing this, you can always zoom in. If you've got QuickTime 7, you can zoom in and see a little bit closer. And that's going to be plus 1 and then minus 3. Okay? Now, again, we've got a complex fraction, and the easiest way to handle this is multiply the top and the bottom by the LCD. This is the shortest way. All right? So if I multiply both terms by x minus 2, because that's the least common denominator, that's the only denominator I see for both these, because that's like over 1, that's over 1. Okay, if I multiply this by on the top, these x minus 2's cancel, so I've got 2 times 3x plus 1. And for the second term, I've got to multiply by x minus 2, and I get 1 times x minus 2. Right now on the bottom, these x minus 2's cancel, so I've got 3x plus 1 minus, and then 3 times x minus 2. Hope you can see that. Okay, now we've got a nice simple fraction. One expression in the numerator and one expression in the denominator. So let's multiply out. What's 2 times 3x is 6x. 2 times 1 is 2. X minus 2. And on the bottom, I've got 3x plus 1, and then negative 3x and positive 6. Okay. Now I've got 6x plus x is 7x, and positive 2 minus 2 is 0. Negative 2 is 0. So I just have 7x on the top. Now 3x and negative 3x is 0, and 1 plus 6 is 7. So I've got 7x over the 7, but 7 over 7 is 1, so I just have x. So I verified that part. So these functions kind of undo each other. I start with x and I end with x. Okay, I started with x here, put it all through this process, and I end up with x. Now let's check the other direction. Okay, so let's take g of f of x, and I left these open a little bit. So I better do this up here so we can see this. So g of x is g, that's the outside function. In this case now, g of x was 3 times something plus 1 over something minus 2. So here we have it, and I left it open here. 3 times something plus 1 all over the something minus 2. And since I have an f of x there, that's where the f of x is going to go, so that's going to go in there. So I hope that makes sense. Okay, and then I know what f of x is, so now I can substitute it. F of x is all the way back up here, and that was 2x plus 1 all over x minus 3. So here we put, instead of f of x, we put 2x plus 1 all over x minus 3, 2x plus 1 all over x minus 3. And then this was plus 1 and minus 2. This was from the g function. Now, again, we have a complex fraction. I have a common denominator of x minus 3 in the numerator and the denominator of this large fraction. So I'll multiply the top and the bottom by x minus 3, which is the LCD, and that's going to clear this real fast. So I'll multiply x minus 3 times this first term. The x minus 3's cancel, and I have 3 times 2x plus 1. Plus, when I multiply x minus 3 times 1, x minus 3 times 1 is just x minus 3. Or I put plus 1 here, we'll take care of that later. And then when I multiply x minus 3 times the first term here, the x minus 3's cancel, and I've got 2x plus 1 minus, and then I've got 2 times x minus 3. Then I multiply this out. 3 times 2 is 6x plus 3. Oops. Get a little more room down here. Sorry about that. So 3 times 2x is 6x plus 3 plus x negative 3 all over. This was 2x plus 1, negative 2x, and a negative times a negative is a positive 6. And then 6x plus x is 7x. 3 negative 3 is 0. 2x negative 2x is 0, and 1 plus 6 is 7. And 7 over 7 is 1, so I have x. So I've verified the other part. Okay, so take a look at that. Hopefully it will all make sense to you. And hopefully it will help.